So today we're going to be looking at lesson 7-2. We're going to be looking at how to understand theoretical probability. So we've compared with flipping a coin and rolling a die, theoretical and experimental probability. So today we're going to look at how to use theoretical probability to make predictions. So we'll look at 3 examples and you're going to try 2 on your own. So I suggest you don't have to write the entire example down, but you should write down that this is example 1 and we're using theoretical probability. So Talia and Yoshi design a game for the school fair. Contestants spin the spinner and win a prize. If it lands on either of the 2 red sections, how can Talia and Yoshi determine how many people are likely to be winners if 500 people play the game? So this is key here. So we can notice that to be a winner, you can either land on this red section or this red section here. So the first step is to determine the total number of possible outcomes. So there are 16 sections. So if you count all the sections, there are 16 and they're all the same size, and 2 of the sections are the same color. So we can then use theoretical probability, and you should write down this definition. Theoretical probability. So because you know all the possible outcomes, you can find the theoretical probability of an event, such as a spinner landing on red. So P represents theoretical probability of an event in a single outcome. So the probability of the event is equal to the number of favorable outcomes, meaning the number of outcomes you want, out of the total number of possible outcomes. So the favorable outcomes here is landing on red. So probability of landing on red is number of red sections out of the total number of sections. So we need to remember this. I would write this part down. So the favorable outcome is 2 out of 16, so you can simplify that to 1 out of 8. So the theoretical probability of landing to be a winner is 12.5%. Now it asks us if we had 500 people play the game, you're going to take 1 out of 8 equals W out of 500. You can set this up as a proportion because we don't know how many winners there would be out of 500. Multiply both sides by 500, so you get 62.5. You could also take 500 times 0.125, and that would also give you 62.5. So the probability is that there will be 62 winners out of the 500 contestants. So you can go ahead and do this one on your own. Our second example, Archie plays a word board game. He places 98 letter tiles and 2 blank tiles in a bag. Players will draw tiles from the bag one at a time without looking. What is the probability that the first tile drawn will be a blank tile, labeled with a letter, a vowel, and a consonant? Okay? So we have to look at a blank letter. What is the probability of pulling out a blank? Well, there is 2 tiles that are blank. So the 2 here are blank, and there's a total of 100. So the rest of these are all 100. So 2 out of 100. The probability of pulling out a red would be 98 because there are 98 lettered tile out of 100. So 98 out of 100. Notice how are the probabilities related to each other? The sum of the 2 favorable outcomes for blank and letter is the total possible value, or all of them, right? For a vowel, there are 42 vowels, so you'd have to count all the vowels, and a total of 100 letters, so it would be 21 out of 50. And for a consonant, there would be the difference of 42 and 100, so it would be 56. So you count all of those. Oh, but then the 2 blank ones aren't included, so it's the difference of the vowels. Or you could just count all of the consonants. I would probably just suggest doing that. Okay, so it's 56 out of 100 or 28 out of 50. So yeah, just keep that in mind. So these are our favorable outcomes. The probability of a vowel, probability of a consonant, probability of a letter, probability of a blank, okay? And these are the values here. Theoretical probability to make more predictions. So Joaquin also designs a game for the school fair. Contestants roll 2 number cubes at the same time. If the sum of the numbers on the 2 sides, or the 2 cubes, is 7, the player wins. About how many winners does Joaquin expect if 500 contestants play? So the key here is to look at all the possible outcomes. So to find that, there are 2 cubes. 2 cubes at the sum of the 2 cubes is 7. So that's the probability. But the 2 cubes, does it say that it is a dice? Roll 2 number cubes at the same time. It doesn't say that they're 2 dice, but they are dice, okay? So it's a 6-sided cube. So the probability, the number of cube, the first cube, you have 1 through 6, and the number of cubes for number 2 is 1 through 6. So then the sum of the 2, so you could roll a 1 and a 1 would give you 2. You could roll a 1 and a 2 would give you 3. A 1 and a 3 would give you 4. A 1 and a 4 would give you 5. Rolling a 1 and a 5 would give you 6. A 1 and a 6 would give you 7. So you need to write all of the possible outcomes down. So you need to make a table here, okay? This is key for probability. Don't try to rush through it, but making a table will allow you to be successful. That is our strategy here. So then we can see that the possible outcomes for 7 are right here. So how many 7s do we have? We have 1, 2, 3, 4, 5, 6. So it would be the probability of the sum of 7 would be 6 out of 36. So 1/6. Use proportional reasoning to predict the number of winners. So this is like the first example we did. So you'll take 1/6 equals W out of 50. It just so happens there are 50 contestants again. So it would be an 83.3% chance. Or excuse me, 83.3 winners number of winners is what you would have out of 500. Okay? Go ahead and try this one on your own. And your homework will be to complete the Math Excel. Please let me know if you have any questions.